2.1 limits. Number 1, the above diagram shows the graph y equals f of x. The following limits. This is the graph. Okay, first is find limit x approaches -4. Yeah, -4, and then check. Oh, -4 is when x is equal to -4. When x is equal to -4, y is equal to 2. So find limit. Okay, first is limit as x approaches -4. Okay, fx, let's say from left, limit is equal to 2. Okay, and when the limit fx, x approaches -4 from right, also 2. Therefore, limit fx, x approaches -4 is equal to 2 because of this one. Okay, same value. Okay, settle for number A. For B, okay, B is here. When find the limit when x approaches -3. Okay, -3 on the left. Okay, this is correction. -3. So from left. Okay, so this one A. B, limit fx, this function, x approaches -3 from left. Okay, only left. So left here. Okay, check. Oh, this is that one here. So the point is 4. Okay, is equal to 4. Okay, and then done for B. Okay, for C, is limit fx, x approaches -3 from right. Okay, -3 from right here. -3 from right. Okay, oh, this is no graph. The graph is here. So it's equal to 6. Okay, 6. This one is 6 from the graph. When -3 from left, the graph shows 4. When -3 from right, the graph shows 6. Okay, no graph here. Okay, -3 plus positive, -3 from right, no graph here. So the graph is lies here, almost 6. You can say 6. Okay, one is C. And then for D, 1D. Okay, therefore limit fx as x approaches -3 is equal to not, change does not exist. Why? Okay, since let's solve this. Okay, to find the limit D, limit fx as approaches -3. So from B and C, since limit fx as approaches -3 from left not equal to limit fx as approaches -3 from right, therefore limit fx as x approaches -3 does not. Okay, this one does not exist. Why? Because of when x approaches -3 from left, the limit is equal to 4. Okay, when x approaches -3 from right, the limit is 6. So limit x approaches -3 does not exist. Settle for D. Okay, for E, limit fx, x approaches 0. Okay, 0 is here. Okay, left and right. 0 from left is equal to positive infinity. 0 from right also positive infinity. So we can write this one for E. Okay, I write here. For E, 1E, limit fx as approaches 0 from left is equal to positive infinity. Limit fx as approaches 0 from right also positive infinity. Therefore, limit fx as approaches 0 is equal to positive infinity. Actually, okay, this one is undefined. Okay, undefined. Positive infinity tends to positive infinity, but we cannot determine the exact value. We can say undefined. Okay, settle for 1E. 1F, okay, as approaches 3 from left, as approaches 3 from right, and as approaches 3. Okay, do this one. 3. Yeah. Left, right. So for 1F, okay, limit fx as approaches 3 from left is equal to, here is, consider 6, 6. 1G, limit fx as approaches 3 from right, here right, also 6. You can say 6 also consider same, same value. Okay, so H, okay, 1H, okay, since limit fx as approaches 3 from left is equal to limit fx as approaches 3 from right, therefore limit fx as approaches 3 is equal to 6. Okay, is equal to 6. Settle for number 1. Number 2. Number 2A, find limit 3 over square root of 3x plus 1 as x approaches 0. First thing, substitute. Just substitute the value. Okay, substitute is equal to 3 over the set of square root of this one, 3x, 3 times 0 plus 1 is equal to 3. 1 plus 1 is equal to 3 over 2. Done. Okay, when you get the value, which one is done? 3 over 2. Okay. For 2b, limit 3h squared minus 2 over h squared plus 4. H approaches set 2. Okay. Substitute 3 set 2 squared minus 2 set 2 squared plus 4. Substitute. Okay. When you get the value, add. So 2 plus 4, 6 minus 2, 4. 4 over 6 is equal to 2 over 3. Done for E. Okay. Okay, 2C, limit 2 plus r squared minus 4 over r as r approaches 0. Substitute 2 plus 0 squared minus 4 over 0. This is 4 minus 4 over 0. 0 over 0. This one consider indeterminate form. Okay, you need to do something. You need to check. This is polynomial over polynomial. So you should factorize. Okay, factorize this one and find the value. Okay, and then we try to solve for 2C. Limit. Okay. Okay, limit factorize. Okay, 2 plus r minus 4. 2 plus r, sorry, not 4, 2. Factorize. 2 plus 2 over r. Okay, I use the concept a squared minus b squared is equal to a minus b, a plus b. Okay, and then next is write limit. You have to write limit. Okay, and let's say simplify this. 2 minus 2 is equal to 0. 2 plus 2, 4. Okay, simplify. This one is r, and this one is 4 plus r. Okay, over r. Then this one can be cancelled. R. Then get limit 4 over r. 4 over r. R is already gone. Okay, 4 plus r in bracket please. As r approaches 0, substitute. Once you substitute, no more, right? Limit. Answer is 4. Okay, settle for number 2, C. Okay, for 2D, limit x minus 2 over x squared minus 8, x cubed minus 8, x approaches 2. First, substitute 2 minus 2, 8 minus 8. This one is equal to 0 over 0 in determinate form. And this one is poly over poly. So you have to factorize this one. Okay, and factorize this one. Okay, this one, let's say right here, x cubed minus 8. So one of the linear factor is confirmed. Okay, try x minus 2. Why? Because of substitute 2 here, 8 minus 8, 0. So x minus 2 is one of the linear factor. So actually this is here, given this one of the, normally this one is one of the linear factor. We need another, we need this one, the one is a quadratic. So either you use non-division or comparison or inspection. So here actually compare the x cube, okay, left and right. You get this one is 1 a, so a is equal to 1, and compare the constant, that is negative 8 on the left. So here is negative 2c, therefore c is equal to 4. Then to find the coefficient of b, let's say the x squared, this is not x squared, 0. Which one produce x squared? To negative 2a, so is b plus b. A is equal to 1, therefore b is equal to 2. Double check. Okay, compare the coefficient of x. This is no x on the left hand side, 0. Which one produce x? X times c, and negative 2b minus 2b. Then c is equal to 4. 2b is equal to 4, therefore b is equal to 2. Then write down here. Okay, x minus 2, a 1, x squared, b equals 2, plus 2b, and c is equal to 4, plus this one x 4. So now proceed to this one. Limit x approaches to x minus 2 over, okay, this one, okay, we already factorize, but just take this one. So we are going to cancel this. No need to factorize quadratic. You don't have factorize completely. Okay, as long as you can cancel the one, this one, consider. Okay, and then the next step, write down the limit. Okay, until you substitute x variable. Okay, then substitute instead, no more limit. Okay, plus 4 is equal to 4 plus 4 plus 4, 1 over 12. This one is for number 2D. Okay. For 2E, limit p minus 9 over cert p minus 3, p approaches 9. Substitute value p 9 minus 9 over cert square root of p, 9 is equal to 3, 3 minus 3 is equal to 0 over 0. 0 over 0 is indeterminate form. Okay, you need to check if this is poly. Even though this is third, this one can be solved using the factorization. Okay, so factorize, you have two methods. Either you multiply with the conjugate or factorize. Okay, let's say we do the first method. Method 1. Okay, 1 to factorize p. Okay, and this one 9. P approaches 9. Okay, so here third p squared minus 3 squared over third p minus 3. Then factorize 9 third p minus 3 third p plus 3 over third p minus 3. So can be cancel. Then this one, just get the function p approaches 9 third p plus 3 in bracket this. Then substitute 3 plus 3 is equal to 6. Okay, and the second method, okay, limit p approaches 9, p minus 9 over third p minus 3 times its conjugate. Its conjugate is third p plus 3 over third p plus 3. Then, okay, try to simplify. Okay, this one, just, okay, write this one 9. Okay, just write this one without expand this one. No need to expand. Okay, this one actually you expand, get p minus 9. Okay, it's the same concept. So like this one. Okay, so also okay. Then and take off p minus 9, p minus 9 cancel, and then get this one is okay, p approaches 9 third p plus 3. Then substitute square root of 9 plus 3 is equal to 3 plus 3, 6. So it's up to you. Sometimes this one can be solved by using the poly or poly factorize or times its conjugate. Okay, that one is equal to E. For 2F, substitute E power 0 is equal to 1 minus 1. E power 0, 1 minus 1. So 0 over 0, indeterminate form. And check, oh, this one is poly, okay. But if you let y is equal to ex, okay, here this one, okay, can be written like this, e squared, ex squared. So y squared minus 1 over y minus 1. So this one consider poly over poly. Okay, then factorize. Limit x equal to 0, y minus 1, y plus 1 over y minus 1. Then this one cancel, can be cancel. So we get this one is y plus 1. Okay, before you substitute, this is x, this is y. So change to this one, e power x, e x plus 1. Make sure we use the same variable before you substitute. Okay, then right here, this one is equal to substitute e power 0 plus 1. 1 plus 1 is equal to 2. 1 is number 2f. Okay, for 2d, limit t squared minus 81 over t minus t approaches 9. So okay, so substitute 9 81 minus 81 over 3 square root of 9, 3 is equal to 0 over 0 indeterminate form. And check, oh, this one is poly over third. Okay, poly third. Okay, other times it's conjugate, but you have choice. Okay, you have maybe you can factorize or the second method is times its conjugate. So let's say you want to factorize. Limit t approaches 9. Factorize this one, t minus 9, t plus 9 over 3 minus 30. Okay, oh, this one you can factorize to get this one. Same like this, 3 minus 30. Okay, and need to adjust. Is equal to limit t approaches 9, t plus 9. This one is cannot do anything because of just like t plus 9. 3 minus 30. So factorize this. 30 minus 3, 30 plus 3. Okay, this one can be factorized. Okay, because of why? Because of this one is 30 squared minus 3 squared, and still get t minus 9. Then before you cancel everything, this is 30 minus 3, while this one is 3 minus 30. Okay, adjust. Before you use, you have to adjust. Okay, let's say this one is 30 minus 3, 30 plus 3, t plus 9 over, I want to take this one negative outside to change this one to like this. Okay, 30 minus 3. If expand, they get negative 30, negative, positive. So now we can cancel this one. Okay, cancel, and write down the simplest form before you substitute. Negative, negative 30 plus 3, t plus 9. Okay, next step, substitute. Okay, substitute. Negative square root 9 plus 3, 9 plus 9. So here is 3 plus 3, 6, 18. 6 times 18 is 108. Okay. You try to solve this one using the times conjugate. Okay, and conjugate. The second method is time its conjugate. Okay, try on your own. Okay, times conjugate. The conjugate is 3 plus 30, 3 plus 30, and continue. Okay, 2h. Okay, substitute x plus 2 4, so 2 minus 2 times 2 4, 2, 0. Okay, 4 minus 4 also 0. 0 over 0, indeterminate form. So next you can times conjugate. So indeterminate form and conjugate. Conjugate is okay, this is the conjugate. Take this one as a conjugate. Okay, so x plus 2 plus 2x over x plus 2 plus x. Okay, let's say if you factorize this one, you need to times conjugate, and then it's equal to limit x approaches to. Okay, this one expand. Okay, this conjugate expand. Get x plus 2 minus 2x over. Okay, we try to factorize this. X minus 2, and the conjugate is third x plus 2 plus third 2x conjugate. And try simplify. Okay, x. Okay, minus 2x, get negative x plus 2 over x. Okay, here is this one is x minus 2. This is 2 minus x or 2 minus x. This one is actually 2 minus x. This one is x minus 2. Means I try to factorize this to 2 minus x. Then this one is just like this one, set to x Okay, and then can we cancel this? Cancel. Okay, because this one is 2 minus x. That is 2 minus x. Then we write this one, limit x approaches to negative. The negative 1 over x times x plus 2 plus 2x. The next step is substitute. Negative 2 plus 2 plus 2 times 2. And the answer is here. Alright, it's okay. Negative 1 over 2 plus 2, and then 4 negative 1 over 8. So for H, answer is 1 over negative 1 over 8. Okay, betul. Number 3, find the limit of the following functions. At x is equal to 2. Here, x is equal to 2, less, more. Here, not equal to 2, is equal to 2. Okay, so everything here. Okay, consider my limit at this number. X is equal to 2. We try do A and B. Okay. Okay, 3a, fx, this is piecewise function. Okay, when x less than 2, the function is 5 times x. When x is more than 2, yes, greater than 2, the function is x over 2 plus. Okay, so this piecewise function change to number line. Okay, number line. Okay, consider at x is equal to 2. Okay, x2. Okay, and for this one, when x less than 2 not included, the function is x 5 minus x. Okay, for x more than 2, the function is x over 2 plus 2. Okay, now find the limit. Limit, okay, we need to find limit fx as x approaches to. Okay, to find. So first, we need to find limit on the left and also on the right. Okay, so this is on the left, on the right of it. Okay, write down the limit. Limit as x approaches to from left. If you can check here, 2 from left here lies here, so we choose this function 5 minus x in bracket. Okay, the next substitute 5 minus 2 is equal to 3. Okay, this is 2. Okay, 2, no, negative. Okay, then that one is on the left hand side. For right hand side, limit as approaches to from right. So from here, right is on the right hand side, and then no line, no graph here. So the graph is, the point is lies in this one on the green color, green line. So we choose this one. The function is x over 2 plus 2. Then substitute 2 over 2 plus 2 is equal to 3. And conclude. Since limit fx as x approaches to from left is equal to limit fx as approaches to from right, therefore limit fx as x approaches to only is equal to 3. Okay, that's for number 3a. Okay, for 3b, piecewise function, given fx for x not equal to 2 and x is equal to 2. Okay, transfer to number line. Okay, add 2. Okay, this is x not equal to 2. So every number set to the function is x squared minus 4 over x minus 2. X squared minus 4 over x minus 2. When x is equal to 2, this is y, actually y. So this is coordinate to 3. This is coordinate, that's one coordinate. So when x is equal to 2, y fx is equal to 3. Just one coordinate. And then we need to find limit. Limit means check on the left and on the right. Okay, so I limit as x approaches to from left. So 2 from left, function lies here, so we choose this one. Okay, over x minus 2. Substitute. Okay, 0, you get 0 over 0. 4 minus 4, 0. 2 minus 2, 0. This is indeterminate form. And check, this is polynomial over poly. So, we need to factorize. Okay, continue. Factorize, limit x approaches to from left, x minus 2, x plus 2 over x minus 2. Okay, this one can be cancelled because of equal. Cancel. Then, okay, get limit x approaches to from left, x plus 2. Then substitute 2 plus 2 is equal to 4. And try to find the same thing for limit. Limit as x approaches to from right. And if you check, actually this is actually the same function. That is x squared minus 4 over x minus 2. Redo. Okay, you can redo same like this on the right hand side, or just ignore on the left side because same one. Okay, right. Okay, limit x equals to 2. Okay, either you do left and right separately, or just like x approaches to only. Why? Because this one on the left and on the right of 2, you get the same function. Okay, settle for 3b. So compare to 3a. Okay, 3a is the region, the domain is less. Okay, less than 2 and equals than 2. So this is the region. For 3b, not equal to and equal to. So you can do number 3. And for number 3. Number 4, find the following limits. Okay, A involve absolute value or modulus. B modulus. This one also modulus. This one also modulus. Okay, for this for modulus, substitute, direct substitute. If you get the limit, something value is done. Consider done. If you get something like 0 over 0, this one is called indeterminate form. You need to define absolute value or factorize something. Okay, or define. If that one is indeterminate form, you need to define. If substitute directly and get the value, means that it's done. Okay, that's number 4. Okay, for 4a, limit x squared minus 4 over absolute value x minus 2 as x approaches to from left. Okay, substitute. Direct substitute. 2 squared minus 4, 4 minus 4, 0. And this one is 2 minus 2, 0. 0 over 0 is indeterminate form. Okay, and then you need to define absolute value. Okay, to define absolute value, so let's say this is absolute value box. Okay, you get positive box when this box is greater or equal 0. Negative box when the box is less than 0. So what is in the box? X minus 2, 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 x minus 2. Rewrite x minus 2. Okay, positive x minus 2 when x minus 2 greater or equal 0 or x more or equal 2. Okay, and then negative x minus 2 when x less than 2. Okay, make sure this is x minus 2, x minus 2. Then, okay, x more or equal to x less than 2. Then, since or change this piecewise function to number line. Okay, and check when x is more or equal to, then circle to the right, the function is positive x minus 2. When x less than 2, okay, different level, less than 2, the function is negative x minus 2. Then here is 2. Okay, then this is on the left negative, on the right of 2. Right, 2. Then now we want 2 from left. Okay, so first thing, rewrite limit x squared minus 4 and x minus 2 left. So x minus 2, check. Oh, x minus 2 from left here. Okay, this is that one, left, and the function is negative. Absolute value, this also change to negative. Negative x minus 2, choose negative. Okay, and simplify. And once you simplify, still you get actually 0 over 0. Okay, substitute, still get 0 over 0. Then this is poly over poly. Then we need to factorize. Okay, factorize x minus 2, x plus 2 over negative x minus 2. And this one equal, can be cancelled. Okay, then rewrite. Okay, this one negative, bring up, x plus 2 in bracket. Next, substitute. You must substitute 2, not 2 less than 2. Okay, first off, negative, positive, just to choose the function. Once substitute, you need to substitute 2. Okay, then the answer is equal to negative 4. Okay, negative 4. So let's say that if you don't want to write down this, define like this, just write this number line and choose this one. And when x minus than 2 means that to the right positive x plus 2, to the left is negative x minus 2. Okay, better for 4a. 4b, limit modulus x minus 3 over 3x squared minus 9x. Okay, x approaches 3 from right. Okay, then you substitute directly. 3 minus 3, 0. And 3, 9, 27 minus 27, also 0. 0 over 0, indeterminate form. Okay, first thing, you need to define. Define x minus 3, modulus x minus 3. So, x minus 3 is equal to 0, x is equal to 0. Then, okay, the number line, 3. So, check, oh, this one is, then circle, to the right is positive, this function. To the left, yang included, different level, negative x minus 3. So we skip piecewise function. Okay, actually it's better for you to do piecewise function, but let's say if you don't want, skip and do number line. But make sure that when x minus something, x minus, not 3 minus x, this one is x minus. So positive to the right, negative to the left. Okay, then this is on the left and on the right. The next step, write the question. Okay, and choose the function. This one, try to factorize x minus 3. Okay, factorize that. Then check, oh, on the, this one is on the right hand side. So this is on the right side. We choose this function. Okay, lies here on the green line. Choose this function x minus 3. then actually change this one to x minus 3, positive, positive. Then because this one equal, okay, x minus 3 equal x minus 3, cancel. Okay, cancel. Then rewrite, okay, 1 over 3x. Then substitute. Okay, the answer is 1 over 9. Okay, 1 over 9. Then done for B. Okay, settle. For C, limit this function 10 minus 7x plus x squared over modulus 5 minus x. X purchase 5 from right. Okay, substitute. Just substitute. Okay, and 10 minus 35 plus 25, okay, is equal to 0. This one 5 minus 5 is equal to 0. Indeterminate form. Okay, then define this. If you define this, let's say you want to use definition. Okay, positive box, this box more or equal 0. Negative box, this box less than 0. So this is 5 minus x, 5 minus x, 5. All the boxes you have to write 5 minus x, 5 minus x. Then rewrite 5 minus x, 5 minus x, negative 5 minus x. Here is, okay, 5 minus x more or equal 0 and x less than 5. So x less or equal 5. Okay, for this one 5 minus x less than 0, so x more than 5. So x more than 5. Transfer to number line. Okay, and take this is 5. 5. If you can see that less, x less than 5. So included to the left. Okay, function is positive 5 minus x. And then to the right, less, x more than 5, negative 5 minus x. Okay, so this is to the left, to the right. That's why if you skip this one, you don't want to write define this, just remember that when you deal 5 minus x means to the left is positive, to the right is negative. When x minus 5 and opposite one, same like number 4a and 4b. Okay, now this case is x negative. X negative means that to the left positive, to the right for negative. Then okay, rewrite x 5 plus 10 minus 7x plus x squared over, and we choose x positive. Okay, x 5 positive, 5 to the right, 5 to the right here, that's here. So we choose this function. Okay, the function is negative 5 minus x. Okay, so change absolute value for modulus this one to this negative. Settle and continue. Substitute and still get 0 over 0, right? 0 over 0 is indeterminate form. You need to factorize only this one. Factorize. So limit x approaches 5 on the right. This is x minus 2, x minus 7. So 10 minus 7. This is expand. So x minus 5. Okay, or take negative outside. So negative change to positive. Then this one equal, up and down, cancel. Okay, simplify, limit x approaches 5, right, x minus 2. Substitute, and then 5 minus 2 is equal to 3. So the answer is 3 for C. Okay, So for D, limit modulus x squared plus 2x minus 3 over x times x minus 1 is x plus 1 from left. So if you substitute the value, confirm 1 plus 2 minus 3 is equal to 0 over 1 minus 1 is equal to 0. So 0 over 0 is equal to, and if you can say this is indeterminate form, then this is, you need to do something, you need to define absolute value. Let's say you want to factorize. This one is x plus 3 x minus 1 over x minus 1. So here you cannot simply cancel. No, you cannot cancel because of property for absolute value. Okay, right. Okay, limit x approaches 1 from left, x plus 3 modulus x minus 1. Okay, so this one can be separated to like this. The property x minus 1. So now we need to define this. This is give problem. Okay, x minus 1. So define this one. Okay, x minus 1. So according this, just do number line 1. So to the right, because of x minus positive, to the right positive function, to the left is negative x minus 1. Okay, negative to the left, to the right. Then next step, just substitute or replace. Here is x modulus x plus 3 x minus 1. So now here is x modulus x minus 1 on the left is equal to this one, negative x minus 1 and negative. And the next step, simplify. Jadi cancel because it's equal. And then limit x approaches 1 from left, negative x plus 3 over x. Okay, substitute value, negative 1 plus 3 over 1 is equal to 4 is equal to negative 4 is constant. Okay, settle for the